the final two skills in this chapter are around real-life graphs. And we're going to look at how we interpret real-life graphs. So here is an example of the cost of a taxi fare, which is given as a graph, and some questions that you're asked about it. Now, normally you need to be really, really careful about what each square represents. So we're going to have a look at how we do that. So if we have a look down here, I go 0, 1, 2, 3, 4. So I'm just going to make a note that each square, one square, equals 1 kilometre. On my y-axis, I go 0, 2, 4, 6, 8, 10. So here, 1 square equals £2. Be really careful, because if we don't get that right, we'll get everything else wrong as well. Okay, so here's the kind of questions that you're likely to be asked in a GCSE about this kind of graph. So, somebody takes a 2 kilometre journey. How much is it going to cost them? Now, always when you're asked this, make sure you draw in your construction lines. So the length is 2 kilometres. So I'm going to go to 2 kilometres here. I'm going to go up to my line. And you must make sure that you draw in these construction lines. The reason why is that even if you don't get the right answer, you will still get the method marks if you do it. There's my 2 kilometres. Reading across from my 2 kilometres, it comes out exactly at £6. And you may find that you will ask questions where it's not exact and you need to understand what the meaning of each square is. So 2 kilometres, here we went up there, we went across, and that gave me £6. Next one, the cost was £7. What is the length? So here it's a bit more complicated because I'm not given £7. So I need to go up on my axis to where 7 is. Well, 7 is going to be halfway between 6 and 8. Okay, so we need to be really careful with that. If it was £6.50, it would be a bit further down. We need to do it to such an incredible degree of accuracy. There's not very much tolerance from examiners for any inaccuracies here. We're going to draw our line across. So we're starting at £7, we're drawing our line across, and we're going to try and work out how many kilometres that is. Making sure our lines are perfectly vertical and perfectly horizontal. I haven't drawn that quite perfectly. I think I've drawn it well enough, and we should be able to see that here I go halfway between 2 and 3 kilometres, which is 2.5 kilometres. Now we've done lots of work on y-intercept and gradient, so we should be able to see what the y-intercept is here. Well, the y-intercept here is £2. Well, what does that mean? In real life, what does that mean that the y-intercept is £2? Well, £2 is the cost of essentially a 0 kilometre journey. So that's the amount that I pay just for hailing the cab in the first place. So here, £2 is my fixed cost. They'll charge me £2 however far I go. That first £2 is just for hailing the taxi. Let's have a look then for part 4 at the gradient. So remember how we found the gradient before? I'm going to take 2 points which are on grid lines. So there's 2 points which are on the grid lines. Here I've gone across by 1 kilometre. I've gone up by £2, from £2 to £4. I've gone up by £2. Be careful, it's not the number of squares I've gone up, it's the value I've gone up. I've gone from £2 to £4, which is £2. So the gradient is going to be 2 divided by 1, which is £2. But what does that mean? Well, I divided by how far I went across. So this is £2, and this is per unit of x-axis. £2 for each 1 kilometre. An additional 1 kilometre would have given me an additional £2. An additional 1 kilometre, an additional £2. So this is £2 per kilometre as my charge. Last thing it asked me, what's my equation? Well, I know that the equation is y equals mx plus c. I worked out what m was beforehand, it's the gradient, so y equals 2x plus my fixed cost plus c, my y-intercept, 2x plus 2. So if I wanted to know the cost of a 20-kilometre journey, I'm now saying that x equals 20, y equals 2 times 20, £2 per kilometre for 20 kilometres, plus my £2 flagfall fee, gives me £42. Alright, pause the video now while you take down those that worked example, and when you're ready, press unpause to have a go at the question yourself. Okay, so this is the graph of the cost of getting a repairman to come and do a repair job in your house. It goes from £50 here at 0 minutes, and at 120 minutes it goes up to £150. Each of those small squares is 15 minutes. What I'd like you to do, please, is to have a go at finding answers to these 4 questions. What's the cost of 90 minutes? If it costs £70, how long was the job? What's the y-intercept and what's the interpretation? What's the gradient and what's the interpretation? Alright, have a go at that now. Press pause while you do so, and when you're ready, press up and pause to see the solutions. Okay, so we should see that your 90 minutes would have cost you £125. A £75 job would have taken 30 minutes. The y-intercept is £50, which is the call-out charge. So as soon as somebody comes over to your house, you need to pay them £50, however long the job takes. And the gradient should have given you, I used this little square here from there to there. It goes up by £25 and across by 30. 25 over 30 gave you 5 over 6. That means it's £5 per 6th minute, or 5/6 of a pound per minute. Okay, give yourself a mark out of 4. Very well done.